Hi guys, I hope you are fine. Guys, we do this problem. I read it first. Sketch the region of the integration and evaluate the double integral. So guys, we are given this integral. And the first thing guys we are supposed to do is to sketch the region of integration. And so therefore with this equation here, I have already drawn the region of integration. That is guys, we are looking at 0. Our limits of dy is from 0, that is y equals to 0 at this point up to this point where we are not sure of it's actually supposed to be governed by this equation root 4 minus x squared. And then guys, we also have 0 to 2, that is along the x-axis. That is 0, x equals to 0 to 2. And so now guys, what we do, for us to be able to get 4 minus x squared, we come and say the limit for x is 2. So if I put 2 here, guys, it is now going to give me 4. That is square root of 4, and then finally it will be 2. And so guys, our maximum on this side of y is 2. And if we draw that region, guys, we use this equation so that when we put 0, we start with 0 here. We shall have this point, that is 0 and 4. And then we can maybe put 1. If we put 1 here, guys, you are going to have 1 is allowed here. That is x equals to 1. We shall have 4 minus 1, which is 3. Square root of 3 will give us now somewhere around here. And so guys, that's how we come up with this line, because we can also put x equals to 2. We shall have 4 minus 4 is 0, so the 0 will come here, and then we join that line by use of a curve. So that is the curve we are having, and it is the same curve guys we are going to use to draw our limits. The first thing guys we are going to do is that we are going to integrate along the, but before we do that guys, we can change this into polar form. We can change this equation to polar form, and that's what I want to do. So that guys, we have our dy dx, this dy dx, first we shall have r is equals to x squared plus y squared. Then guys, we also have r, that is dy dx, this also gives us in polar form, it is going to be r dr d theta. That is our dy dx. And so guys, we now can change this equation into that format. So guys, what we are going to do, we'll put this equation this way. We shall integrate guys first in radius, that is along the radius, and that along the radius is from 0 up to the where our radius is, and that is at point 2. So guys, we shall integrate from 0 to 2 along the radius, and so therefore guys, we can actually write this equation now, whereby x is also equal to r cos theta. So I'm changing everything to polar form. So x is r cos theta all over, this is the square root of r. The square root of r squared, this is actually squared, so this is going to be r. Then instead of dy dx, guys, we are going to have r dr d theta. So guys, integrating with respect to r, guys, we are going to move from 0, that is from this, the radius 0 to 2. And then guys, we are going to integrate yet again with respect now to along the circumference. Along the circumference, guys, this is theta equals to 0, theta equals to pi over 2. And so we shall put here 0 up to pi over 2. And therefore, guys, now we have formed our equation of integration. So guys, we can now cancel that and that. And so we are going to have from 0 to 2 r cos theta dr d theta. Then from 0 to pi over 2. So guys, we do that. So this is now going to be, we integrate with respect to r, we shall have cos theta integral from 0 to 2 r dr. First, we integrate with respect to r. So guys, this is now going to give us cos theta r squared all over 2 from 0 to 2. So guys, we are going to have cos theta 1, that is 2 squared, which is 4 over 2, and that 4 over 2 will give us now 2, like that. And so guys, this is what we are having, because 2 times 2 is 4, 4 divided by 2 is actually 2. And then from there, guys, we can now integrate with respect to theta. So guys, we are going to have 2 cos theta d theta, now from 0 to pi over 2. So this is going to be 2 cos theta, we integrate that to give us sine theta, and the limits is from 0 to pi over 2. So guys, this is now going to be 2, then sine pi over 2 minus sine 0, which is 0. So guys, this is now going to be our solution. And our solution, guys, here is going now to be sine pi over 2 gives us 1. And so therefore our solution is going to be 2. So guys, thank you for listening to me. Bye bye.